So, shell scripting 10010.
Or 2013.
Yes.
Yeah. Excellent. Welcome. How many of you are from outside of Pennsylvania?
Cool.
Wow. That's awesome. How many of you have been working with Macs more than 2 years? Okay.
Yeah.
How many of you have done shell scripting in the past? Okay. All right. So, as we move through this, feel free to modify some of the things that we're doing in some of the exercises to play around with them, and ask questions.
Feel free to give us a better way to do the things we're doing.
Or suggest other ways.
Yes. So for those of you that are following along on your personal laptops, if you'd like to look at the exercise files and handouts, scripts, you can download them from this tiny URL.com, PSU Mac Scripting 13. That includes a PDF of the keynote, scripts, and exercise files.
Did everyone get that URL? Leave it up there for a second, okay? All right.
Mm-hmm. So thanks for asking that. That's a great question. For the lab machines, they're going to be on the desktop, and we're going to need your help in ensuring that all the machines are woken up so that we can push this with ARD. So if everyone that's sitting at a lab machine can make sure it's awake and opened up, actually 126 there. If you're not going to use it, that's fine. You can let it go. If there are any machines, lab machines that are closed, just let me know. Otherwise, I'll think that they're not working, and then I'll get worried that the network's down. Of course, it's not really up, so. Okay, so all the lab machines that are going to be used are awake and up. And I'm going to push this to the desktop folder, shell scripting PSU MacConf13.zip. And if it's out there, I'm going to replace the item. Okay, everybody should have it. As we go through, if you don't have it, just raise your hand and we'll get it to you. Or you can download it from the tiny URL as well. Got it. Thank you. Okay, go ahead, Jay.
Excellent. Here we go. Excellent. So I'm Jay Hoff. As you probably know, during the intro this morning, Rusty and I work together in the same group. He works on the Mac side. I work on the Linux side. I'm the group's Linux sysadmin. But as you know, shell scripting is a core component of Linux scripting and Linux tools. I've been with the group for about 4.5, 5 years, and that should actually say @JHoff. Not your fault. I think we put that in the cell. Oh, you have to correct that. My Twitter.
So I'm Rusty Myers. I'm a Mac administrator for ITS. It's what I look like in day-to-day operations. Email rzm102@psu, and follow me at the Spider on the Twitters.
That was just yesterday.
Yeah. That's why the Wi-Fi doesn't work.
Yeah. All right. So what's Bash? Bash is the shell interpreter. It's the command interpreter. When you write a shell script, it is Bash that interprets what's happening behind there. The binary for it is bin bash. So when you launch a bash shell, you open up terminal window. You actually you kind of work inside of a bubble. In that case, that's called bash. Everything that you do when you start a script or something runs under that process ID. All right, that's called the kind of parent. And then if you spawn a shell or spawn a script or something along those sorts, it's bash that starts a new process and kind of runs that process. And when the process finishes, it returns something back to the parent process.
So the Born Again shell, or bash, was programmed, beta released in 1989 by this man, Brian Fox, and it was a replacement to the Bourne shell, which we're not going to talk much about.
How many of you remember just the shell? The Bourne shell. Anyone?
Yeah.
Yeah, exactly.
There are a lot of different shells, but today we're just going to talk about scripting in the bash shell.
Yep.
But a lot of these concepts are transferable between different shells. And you can get into the caveats on what different shells do differently.
Yeah, different shells provide different utilities. For example, how many of you have been working on a command line and you can hit the up arrow key to scroll back through command history, right? Well, for some of you that have hair color like mine, I cut a bunch of it off, but it's still there's some left. Back when you had just the bourne shell, you didn't have that ability to use the back arrow, the up arrow, to scroll through your history. So that's what some of the different shells provide, different utilities that are available to us. Paths. Paths in shells are extremely important to understand what they are and what they mean. So if we're talking about a relative path, that means from whatever the working directory you are in, if you type a command, the interpreter or bash is going to say, well, I'm going to look for that file here. All right? Versus a absolute or full path, which always starts with a slash. All right? So if I was in /bin, for example, and I typed in the word bash, I wouldn't get an error because bin bash, bin is where the file bash is located. All right? If I am in the temp directory and I type in just bash, it's going to give me an error and say command not found. Right? So I would type in /bin/bash. Gives it the absolute path to a particular file or directory. All right? Why is that important? Anyone? Bueller?
Anyone?
Bueller? You got to know where the command lives, right? Now, where that's really important is when you're doing a shell script and you start inserting, different commands in that shell script. You might think, oh, well, I know where that file is, so I'm just going to actually type in that command, right? Good shell scripting format is to type in the absolute path of a command. Why? Because you may get on a system that for whatever reason, that file isn't in the standard location. All right? What's another good reason to use absolute paths? Exactly. Right? Because somebody could, if you go to somebody who's very security conscious, and I'll kind of clean that up. They're very worried about security. They will always type the full path to a command. Why? Because somebody could have hacked into that machine, changed the path so that when I type in
Echo.
What?
Echo.
Echo, which is a command we'll learn about if you don't know what it is already. It actually may be a malicious script that does something in the background, but then the last thing it does is it does what you ask it to, right? And they stick that, could be in anywhere, but if they put it in, if you use the absolute path, then you know that you're actually calling the command that you're looking for.
So we have a quick example of relative and absolute paths here. We use the pwd command in a terminal that prints out the working directory that you're in. So in this first line, we use pwd and we get the output of users Joe. So we're in the users Joe home directory. I think everyone kind of is familiar with the home directory on OS X. And if we have a text file on our desktop, when we do cat desktop text.txt, that's going to echo out what's in that text file, in this case, hello. We could also echo out the same text file by giving it the absolute path of users Joe desktop text.txt. So that's a quick example of relative and absolute paths.
All right, so let's take a look at a couple of the basic commands, which you may or may not be familiar with. How many of you are familiar with the man command?
Cool.
How many of you are not? Everyone's familiar with man pages? How many of you use man pages to fall asleep at night? Right? If you haven't,
Yeah.
What's that? Or during the day too, right? Yeah, they can be very long. So again, there's a bunch of commands. Man and approval essentially do the same thing to give you somewhat different outputs, but allow you to search for different options to a command. Which command? How many of you guys know what which is? What does which do? Correct. Yep. So if you type in which space followed by command name, it should provide you with the path to that particular file. Cat command, output the contents of a file. Echo space something, if you're typing this on a command prompt, we'll replay that content back to standard output, which is the terminal. We'll cover grep in a little bit later. Sleep command, that essentially sleeps that process for X amount of time, depending on what numerical value you provide. Clear clears the screen. Reads input from the keyboard and sets it to a particular variable value. ls lists the contents of the particular directory you're in. Chmod, how many of you have used chmod? Change permissions. Chmod. How many of you say chmod? How many say chmod? A couple. Tomato or tomato?
Bacon.
Is it great tasting or is it less filling? Some of you got that, right? And then finally, tr is a command we'll explore a little bit later as well. Translate.
Some of the OS 10 commands we're going to be looking at today are swvers, which gives you the system version, some build information, system profiler, which gives you a lot of information about the system, system setup, network setup, disk utility, and open. And there's a lot of other commands that we're not going to touch on today that are OS 10 specific. Some of you may have seen these before, but yeah, there's a lot.
Okay, shell variables. Shell variables are traditionally set when you log in. And you can see what some of those are by running a command called env. And you'll see that the value of it, so you could do echo space $pwd. That echoes out the value of that variable. All right. If you just type in echo space pwd, you'd get back pwd. All right. The $sign specifies that this is a variable. All right, and it'll output the contents of it. So in this case, pwd, print version directory, $user, who's my current user, $shell, what's the current shell, and $path. All right, $path is a good one to learn what it does, because sometimes you'll type in a command and you go, why isn't this working? Right? There is, I know that you can change users by using a command called su, right? And sometimes when you run su, it doesn't actually inherit the path of the user that you're trying to become, so you try to type in a command and it doesn't work. Why doesn't it work? And then you type in the absolute path, if you happen to know it, and it does work, right? So echoing out $path will help you understand, well, this is where the shell is searching for to look for this command. So if you don't supply an absolute path, the shell looks, well, what's my $path? What's the path that I should look in? And it does it by order, right? It looks first in the, whatever is the first part of its path, and then continues forward.
Shell variables are also variables that you should try to avoid reusing in your script. For example, if you reset the path variable to something in the beginning of a script and then expect the echo command to work, in the end, it fails to find the echo command. And then you spend 20 minutes trying to figure out why it doesn't work, and then you realize that I used the path. I mean, you used the path instead of a different variable that's more unique. So try and use env to list the variables you shouldn't use in your scripts, and use something that's more unique to your script when setting variables. We're talking a little bit about special characters. They are, again, used by Bash to interpret things. I'm not going to go through all of them, but you should try and avoid using some of them. And if you don't understand how they work, avoid using them. If you want to use them, do a Google and figure out what the command is. Here's the list of a lot of them, and spaces are also special characters. A few of them that we're going to touch on today are the commenting, $, the $sign for variables, the asterisk for wildcards, and the period for current directories.
So, quoting. So, what if you have a file that's called asterisk? It's a dirty trick to play at someone who doesn't really understand the command line. If you have a file named star, that's the only thing you see when you do an ls, right? So one of the commands to remove a file is rm. There you go. So, RM star, remove everything, right? Whoops. Yeah. So how do we tell the shell, no. It's a file name. Just remove that file name. Don't actually treat it as a special character. We do that by quoting, all right? There's different quoting mechanisms that you can use. They have different levels of capabilities, if you will. If you want to escape a single character, you use the backslash, all right? If you have a file name, remember, a space is a special character, all right? In Windows, you can call a file, hello, my name is Bill, with spaces in between it, all right? In Linux and in Mac OS, if you're on the command line and you say create a file name called hello, my name is Bill, you'll end up with hello, my name is Bill, 5 files. All right? If you put a backslash immediately after each one of those words, followed by the space, the shell will go, oh, well, you actually mean that to be a space. Okay, I won't treat that as a separator of options, or arguments, excuse me. Double quotes. Double quotes escape everything from the shell except for $. Make sure I get these right. The back tick, which is a back quote. It's usually up above the number, below the tilde, excuse me, next to the number 1 key. And then also the backslash. All right? And then single quote escapes everything. All right? You'll see as we move through this why this is important to understand the capabilities of those quoting mechanisms. Yes?
When you say, just to give a general idea, so say escaping a character, can you explain that more?
Thank you. Yes, absolutely. What you are doing is you are preventing the shell from interpreting it as a special character. All right. So, for example, RM space star would remove the file or anything within that particular directory. If I did RM space backslash star, it will say, oh, this isn't a special character meaning everything. This is just an ordinary
File name.
file name. So in this case, it would treat it as just an asterisk, and it would remove that file, and only that file. So escaping or preventing the shell from interpreting it as its meta character or its special character's value. Does that make sense? Okay, good question.
Here's a quick example of escaping. If we echo PWD, the variable PWD, you can see that it's set to the working directory that you're in this case, user student. If we put double quotes around it, we will get user student. But what will we get if we put single quotes around it? Anyone? You get that right, the $PWD. And then again, if we use the backtick, or the backslash in front of that $, we'll get just $PWD as the output. The shell does not interpret that $, as meaning the next set of characters is a variable. It just means it's part of the string.
So just kind of pausing for 1 second. Why would I want to do something like this? Echo space single quote $PWD single quote. Perhaps in the shell script you want to output something to the user that says, hey, this is the variable that I'm using, or this is the string of text that I'm using to show it to them. Right? So if you did echo space $PWD in double quotes, it's going to give the value of that variable. But if you want to actually see the exact syntax for it, you could use a single quote. Okay, shell script. Shell scripting is an interpretive language, which means you have to have an interpreter to read it. If you don't have the interpreter, you can't really, it won't run it. Not compiled like a C program is. Here's some examples of different scripting languages: Bash, PHP, Python, Perl, and Ruby.
Bash script takes multiple commands that you would run one at a time in a terminal window, and you combine them into a text document to create a repetitive process to allow you to repeat a common task that you have to do or gather common data.
One thing with shell scripting is that every line of code that you put in the shell script, you can test on the command line. So if you're doing some coding and you're like, this just isn't working, and you want to do some troubleshooting, copy that particular line of code, toss it onto the command line, and run it. If it runs on the command line, it should run in the shell script. All right, so you can do some testing with running your different commands that are in the script on the command line.
So why we created repetitive tasks, easy to automate. It eliminates errors because you don't have to type in the commands individually each time. You just type them once and run them again. You can also delegate these tasks to other people, so you can give someone a script who doesn't know the command singularly, and they can run a script very easily. It's self-documenting. The commands are all there. If you have a lot of comments, that's very helpful, so that other people can follow your script and update them when necessary. And in the long run, it saves time.
Script editors. How many of you would say you're comfortable with working in a command line environment? Okay, excellent. So there's different editors. There's GUIs, TextMate, BBEdit, Text Wrangler, some examples there. Command line, Emacs, Pico/Nano, and VI. VI rules, right? How many of you like VI? How many of you hate it and wish it would go away? Okay, all right. I always say you've got to learn VI because it's the one editor you can guarantee will be found on any Unix, Linux system out there by default. Enough said on that. It was about 50-50, so I won't speak too much on VI. I don't have enough numbers on my side. Go ahead.
So we're going to talk a little bit about a script format. Bash doesn't care about extensions, but most of the time you're ending your script with the extension that it's going to be interpreted with. So in this case, Bash, we end with .sh. Why we don't end with .bash, I don't know, and I should have looked that up first.
It's a carryover from the shell days of sh. So everyone knows that sh is a shell script. So
that's why we end with .sh. You can start the file with a period to hide it, and try to avoid special characters and spaces within the name of the script.
So if you name a file .hidden, and you do a regular long listing or regular listing, the file won't show up. It's kind of like sliding it a little bit underneath the map, but of course you just lift up the map, and there's the file. You use a -A for the ls command, and that shows you all files, including hidden files, based on the command line.
The first line of the script is what we sometimes refer to as the shebang, and it tells the Bash interpreter, or it tells Bash which interpreter to use. So if you're running a Perl script, you could use user bid Perl as the interpreter for the rest of your code.
Yeah, so the first line here, you notice that it starts with a # followed by an exclamation point, and then the path to that particular interpreter, in this case, bin bash. Again, as Rusty mentioned, if you're creating a Perl script, user bin Perl would just be up there instead of # bang, in this case, exclamation point, user bin Perl. All right. Then it's just kind of good to put a script description. What is this script doing, right? I can tell you a handful of times that I've created a script and gone, I'm not going to, it's a 10-line script. I'm not going to document what it is. How many of you have created script, either command line or something else, and then a year later you go, it's only 10 lines, but why did I do this? So throw a description in there. It's a good idea just to document it, so in case your script gets out, or within your particular company, somebody to come back to if there's issues with it, and then date it. And then after you do that, throw in your code, followed by an exit of 0. Exit simply tells Bash that this script has exited cleanly without errors.
Here's a quick example that we put together. Hello.sh uses bin bash as the interpreter. It's a script that will say hello, written by Jay and Rusty on May 1st. And we just echo out hello macadmins to the console. And then exit 0.
Execute bit. When you create a new script, by default, it does not make that script executable. It's kind of a security enhancement or security feature, right? You don't want to create a script that's automatically executable. So when we're looking at a particular file, in this case we do a long listing, there are 3 fields of the basic, what's called POSIX permissions. User, group, and then everyone else. Okay? Some people say it's owner group, but for the example, we use user because part of the things with the chmod command is setting the user bit. So there's 3 fields, read, write, and 3 bits for each field, excuse me. Read, write, and execute. All right? Incidentally, a directory cannot be executed, but you have to have the X bit set on a directory so that you can have access into it and read the contents inside there. Okay. That's catching me off to this if you want to know more about that. Long listing sets those, or shows you those permissions. There's 2 ways you can use the chmod command. How many have used what's called an octal value of setting values for those? It's chmod space a number 444, 777, followed by the file name. That doesn't work in shell scripts. All right, so you have to use what's called the symbolic method. All right, so what you have to do is chmod the field user, group, or other, UG or O, followed by a plus or a minus, and then what do you want to set that bit to be? Are you adding the execute? Are you adding the read permission? All right, and then followed by the script name.
So here we have an example of a file, hello.sh. If we do a long listing on it, ls-l hello.sh, we can see the 3 groups, user, group, and other. Right now, user has read-write, group has read, other has read. If we want this script to be executable, we can run the chmod user plus execute on hello.sh. If we do another long listing, we can see that the execute bit was added to the users group. And if we run the file, we get hello Mac admins.
All right. So now we're kind of going to start transitioning away from the straight lecture. And we're going to move into start doing some hands-on stuff. We're going to do a brief description of what that short little exercise will be. And then we'll move into the exercise. And we'll come back and do a description again about what the next exercise will be. And then we'll move into that exercise and so forth. If you have any questions when we're moving through these, Rusty and I try to create this session with as much hands-on as we can. All right? That empirically, well, that will usually cause some people typing errors as we start typing through this. Raise your hand up. We're going to be floating around helping out. All right? Ask questions.
So for the first terminal exercise, we're just going to drop into the terminal and run some of these commands. We're going to get a feel for the output of these and start to figure out how we can use these as part of an entire script to run an inventory on a system. So if you open up your zip file that everyone has, inside there we have, let's see, thank you. You'll have, I don't have the PDF, but you'll have the PDF of the presentation. You'll have the exercise handout and the exercises. So if you open up exercise 1 handout, that's the first one we'll be going through.
If you don't have it, pop your hand up so we can help you out if you don't see that. Good? All right.
Don't have it? Don't have it. Are you on your own machine? No internet access, so you don't have it. That,
3 hours left to download.
3 hours to download?
Yeah. Mine's only 1 minute.
Maybe I should remove for that.
All right, so if you're still downloading it,
Yeah.
and you're sitting at a spot where we have the lab, our lab machine,
Yeah.
Look over your shoulder.
I think use a USB drive.
If not, we can float around USB drives. You've got one? Who wants? We've got a couple of USB drives floating around.
Yeah. I'm not sure I have mine.
Thank you. Anyone else want a copy? That's waiting for something to
On the floor,
download?
right there. Jay.
Oh, sorry.
Oh, I remember. Oh, wait.
Did you say you use VI? I got it. You know what? I'll buy you a drink out there. Come on over to the fountain machine. Did he really? Okay, I wouldn't get into a ring with him. That's,
Only active for the ones that
Correct.
wow.
So we're 16 port 100
That's
meg
spell
switches
check
under
you
the
tried to
desk for all
miss.
16 ports. We only have 8 port gig switches under
Anyone
the desk.
else need a copy?
So
like when this conference is here,
they get plugged into the 100 port, but we only had 8. So we only had 8 machines, 7 machines that we could plug in, one for the uplink for the 8 port switch. So we couldn't plug in the 16 port switch to activate the rest of the ports. So the other ports are unplugged.
Who else needs files?
We ripped out the 10100 and put it in our gig switches. Yeah, for net booting,
Yep.
net restore,
Thank you.
that kind of deploy studio, those things.
Thank
yeah.
you.
Yeah, so those ports are not active. Yeah.
All right, so we're good to go? Thumbs up all the way around?
Well, we'll keep disseminating those exercise handouts, but if you open up the first one here, and hopefully text edit works fine, we'll run through the terminal side by side here, and just type in PWD, see what the result was.
So go ahead and just kind of run through that little short exercise yourself and see what some of the results are.
Excuse me?
Usually. Question was, are variables case sensitive?
Variables, but commands.
Usually. It's
Yeah.
it's good practice to
Yeah.
always assume
Yeah.
case sensitivity. I know that you can format the file system to be case insensitive. However, good Linux, Unix, which is kind of in the world we're operating when we drop the command line, is to assume case sensitivity.
Yeah. So if there are any questions, raise your hand. And in a minute here, we'll get a feel for how many people are still running through the exercise before moving on to exercise 2.
How many of you are familiar with that are done? The link command. LN? LN? I taught a class on once, and I had everyone link Windex to clear. So to clear their screen, they typed in Windex. And it would clear the screen.
So I'm expecting for most of you this is kind of a review at this point. Seems like we had a lot of good experience in here. Questions?
I like autocomplete. After I've given it, I don't know the right name, like the example is.
Tab completion.
Yeah.
Yeah.
That was just speaking
So
about.
like system setup, that would autocomplete.
Right. No, I don't believe it will, because that's a path, right?
Yes. Yeah, so excellent. Thank you for bringing that up. That was something that was in Bash that wasn't in Shell. Tab completion. So if you start typing in a command, and say it's like
System profiler.
System profiler, right? Excellent, right? So here Rusty hits the tab key. What the shell is attempting to do is it's going to look at that path variable and try to match. And it's going to say, all right, in my path, I see I've got system profiler, system keychain, and system setup. If he now hits the underscore and hits tab, it says, oh, well, there's only one thing that matches that. All right? The question is, once I hit the option, it doesn't fill it in for me like if it's a long option. That's because that's not part of a path. That's an option unique to that particular command. So it doesn't know anything beyond just searching the path for it. Excellent. Thank you for pointing that out.
Yeah.
It's not really interesting, but I noticed that in a bunch of Linux, well before viewers, it will fill out.
Oh, Oh,
Cool.
does it really?
It's mind-blowing. It's so useful.
That is awesome, yeah.
Yeah, any option, any sort of type of thing. I won't do it to do, but you know, like, really
Okay.
Is that right? Okay, so tomorrow's session is going to be on the Mac, so we're going to refresh these and put a bunch on all of them
Yeah.
tonight.
Anyone still running
What's your
through
name?
exercise 1?
Henry's going to be doing that tonight. So
Yeah.
tomorrow morning, see Henry, and we'll have it going.
Question.
Thanks, Henry.
Just something I want to point out that when your system set up usernames,
Yeah.
you need to use admin to make that wrong.
So you need a sudo? Or, okay. Maybe get...
Okay. So while he's correcting that, two things happen there. First of all, maybe the command won't run under your current user privileges, right? Okay, so we have to escalate those up to something that's a little bit more important than just the lonely user that you guys are. Second thing is remember the path variable? When you log into a machine or when you open up a command prompt, it looks to see what paths I should have for that particular user. The root user, or the super user, or the admin user may have a totally different set of paths that gives them access to directories where those tools are located. So if it says command not found, that means, first of all, it's not in your path, which means, oh, I'm not the admin user. All right? So there's a command that you can run to escalate your privileges.
Sorry. System setup's being wonky. System setup should work. So you're saying sudo. Did anyone get this to work? System setup, get computer name?
Yes.
Well, okay.
Are you on your local machine? Awesome. Okay, perfect example, if I may. So what happened is, on the lab machines, it's working. Is that right? Okay, that user is part of the admin's group. Remember the permissions we talked about? User group. That group that you're part of,
Okay.
the permissions that are assigned to that particular group are what you would operate under. Ordinary users, I subscribe to this as well, is I don't operate under an account with admin. So every time I have to sneeze, it says, sorry, you don't have permission to sneeze, I escalate to run that particular command, in this case, network setup.
Okay.
Does that make sense? Let me just stop for 1 second. Sudo, does anyone know what sudo is? Or who does not know? Everyone's familiar with what sudo is? Okay.
Okay. Okay. So that was exercise 1.
Oh, okay. Echo command, we've talked about that a bunch. We already know what it does. Output's a string to standard output. Standard output, by default, is what? Monitor, right? What's the big deal? When we start talking about redirection, you redirect that output from the monitor to somewhere else. All right? Standard input, just for the heck of it, is keyboard. By normal. Double quotes around string, yes. Again, spaces, so forth. It's a good idea when you type in echo space something, echo hello. Even if it's one word, put double quotes on it, around it. Get used to using the quoting.
A couple of reasons to add echoes are for debugging purposes and for informational purposes. We're also going to be looking at network setup in this next exercise. We're going to use at the output the IP address of the Wi-Fi and Ethernet ports, as well as we're going to talk about Ethernet 2 for Mac Pros. And man network setup, if you want to, for some usage right now. But at this point, we'll move back into the exercises. I think it's number 2. And open up exercise 2. Yeah, switch both of them. Yeah. So, go ahead and run through exercise 2. If you have questions, let us know. We'll give that a couple minutes. Exercise 2 is where we start our script, so it gets a little bit more advanced. We'll open up the text wrangler, which is in your applications folder, and start typing in there. You can also follow along if you want to with the example scripts, which are developed based off these exercises.
So,
I was wondering if it would do that. Yeah. That's my Apple. Yeah.
yeah,
Can you do anything with
your
it?
Apple ID, just write it down on a slip of paper and hand it to me. I'll give it back to you in about, well, we got slow wireless, so it's going to probably take me a little while to download things. Thank you.
Is it asking you?
So as you will notice, every one of the exercises that you're going to start doing are going to build upon each other. So the goal is at the end of this, you should have a script that is fully executable, hopefully, that will do a series of tasks for us.
Cheat sheets on the projector.
Cheat sheet, yes. So in this case, the script that we have up here, 02_inventory.sh, is an example of what we're looking to get. Yes?
Yeah.
Okay. Use text edit then.
Sorry about that. I thought it would be easier. Apparently not. We'll just push out a new binary.
I'm hesitant to say it, but I will because you know my stance. Just use VI. Yeah. No one has any tomatoes to throw at me or anything, do they?
All right, if you have Text Wrangler open, I'm going to replace it with a non-Apple Store copy. So that's copying out now.
And you can drag it. Or if you're going to type it in, just go ahead and type it in. So go ahead and just start typing. What you do is just save that.
Okay, you guys can give another shot at Text Wrangler if you want to. Or you can stick with what you've got.
What's that? Sure. We're going to create a script. Alright. And we want the script to do a couple of things for us. So we're going to start the script with the shebang, which is a pound sign, exclamation point, slash game, slash back. So you just type in the short script here. And if you look up on the screen, that's kind of what we're doing. That's what you're doing right there. Hey, Rusty, can you throw that example back up there for a moment? Thanks. So, well, okay, here. So, you've done this, right? Write code to echo out the inventory script. So, echo out inventory script. If you look at this, see where echo is? Echo space, inventory script. And then you get recon, because you're creating a script. Alright? Write code to generate the script. So then you look up there, field number 16, networks, right up there. Dash this call. That's all one word. That's all hardware works. All.
So if you're using Text Wrangler, it has this convenient feature in the top menu bar to allow you to run the script in a simulated terminal. And it opens up a new Text Wrangler window with the output of your script. So it's a quick way to test this code without running it in the terminal. Just using the defaults, it'll give you the output of your script. Kind of convenient when testing things. That was in the in Text Wrangler. There's a shebang on the top menu bar, and you can just run. BBEdit has it as well. I use TextMate, which has a bundle for running shells as well. Yeah. Command R, I think, in most of these applications. Yeah.
Running an interpreter is about a slash page. I mean, slash message versus slash bash. Do you have preference?
I don't. I suppose my preference is bash, but my reasoning is not substantial. It's just the way I've done it, which isn't a good reason. But I got used to it. I would have to Google it for specifics, but I'm sure there's like those minor details that Shell will do something slightly differently from Bash, and it's probably more in test statements than anything. But I just stick with Bash, and I've learned to live around it. James? Maybe equivalent? It's just an alias. On OS X, it's not an alias. On most systems, it is an alias. But yeah, so good question. I'd have to Google it for the answer. C shell, T shell. Yeah. Yeah, and I can't really touch on any differences between the different shells. I just don't know. If anybody does know, feel free to.
So then you go to your command prompt.
So everyone pretty much done with exercise 2? Anyone still working on it? The what? Oh, sure. That little guy. Pound dollars. Mm-hmm. Well, we've got basically our very simple script right now. Gives us some information about the hardware ports. Gives a little information about Ethernet, Ethernet 1 if it exists, and some Wi-Fi information. So I'm going to run this real quick and just take a look at the output. Our echoes we put at the top for the inventory script that kind of kicks us off, lets us know what the output is from. We go through network setup list hardware ports is this first section here. It lists all the different hardware ports. Maybe a little too much information for what we want in the end, but right now this is Bluetooth, Ethernet, FireWire, and Wi-Fi hardware ports. This also allows you to match up the name of the hardware port with the device identifier. So on a MacBook Air, EN0 is Airport. On a MacBook Pro, EN0 is Ethernet. On a Mac Pro, who has 2 Ethernet ports, it's EN0 is the first Ethernet port, EN1 is the second Ethernet port, etc., etc. And with new devices, I'm sure they'll switch those around some more. So allowing, I think that printing out what the device name is and what device it actually is looking at, and then the hardware information is helpful when you're doing this kind of inventory. Yes? Sure. You do not. No. These commands are completely separate. It doesn't matter what order you run them in. One of the things that may matter, and we'll talk about this later, is the name of things. So Wi-Fi, I believe, was introduced in 10.7. Before that, it was Airport, 10.6 and before. And OS 9, I think it was something else. So you kind of have to
test it on the command line.
Test it. Yeah.
If you're getting an error in the script, copy that particular code out, drop it on your command line, and see if it runs there. Does that make sense? Okay.
Mm-hmm. Correct. Yeah. So I'm doing that because in my output then, I can see that this is the Ethernet. So this is my echo, Ethernet. Is that right? Yeah, I believe that's right. Ethernet, and then the Ethernet configuration is here. Ethernet 1 then is my echo here. And then this is the output from Ethernet 1. Network setup, get info, Ethernet 1. There is no Ethernet 1. And then I echo airport, and then I output network setup, get info Wi-Fi underneath that. So,
Sorry.
go ahead.
He could have put, instead of just echo Ethernet, you could have put in a set of quotes, here is the Ethernet information. So that when the output comes down, you can see what it is. Incidentally, you can throw a space in your output if you just do an echo with nothing after it, or an echo followed by two empty quotes right next to each other. So you do echo, space, double quote, double quote. And that puts a blank line in underneath it when you actually run it. So if we did it up here, where it has Ethernet, if you'd done an echo, yep, just like that. Throws a little space in there.
Mm-hmm. That's a good question, and we've actually got that as part of script 4. So let's talk about that in script 4 and on.
So as Rusty's kind of moving on to the next exercise, we have, the script gets more complex as we continue to move through here. We have as much information contained in our presentation for probably about 2.5 hours. All right, we put it in there so that you have something to take away with, and hopefully it will give you enough foundation that you can look at the final output, the final content of our last script to see what it's doing.
So we've got about 21 minutes left for this session. I think what we're going to do for the rest of the exercise is ask you to open up the exercise script that we've provided for you and look through that and kind of understand that and ask questions if you have it. We'll take about 5 minutes, I think, for each exercise going forward. For exercise 3, we're going to look at system profile and system setup to print the system hardware data and computer name. We've already seen these when we ran them solely in the command line. So exercise 3 is going to deal with putting them into the script and then seeing the output when we run the script. And you didn't see my slides, did you? I just realized that. That's all right. Exercise 3. Real quick, I'm just going to open up. Instead of opening up exercise 3, I'm going to open up script 3.
It's important to be able to read a script and understand what's happening with it. Incidentally, and forget what day this is, we have a 75-minute session that's an open lab.
That's today.
Is that later today?
That's today, the fourth block today. This will be an open lab, so if you have questions, you can come back, use the machines, ask us. I'll be here. Will you be here?
Yeah.
Okay. I think another person will be here as well. Pretty much, yeah, open lab.
Yeah, it's open lab for the conference.
For anything. Doesn't have to be shell scripting. It can be Deploy Studio, Monkey, Puppet. We'll try and answer any questions or find a speaker that can. So script 3, we build onto it by adding the system setup command and the system profile command to output that information. I did not add any echoes there. And the reason I did not do that is because I wanted you to kind of get overloaded with the amount of junk that this script writes when you run it. A system profiler alone just gives me anxiety when I try and run it alone. So system profiler, I think, starts here. And this is just the hardware data information section of system profiler. If you run it without that second command, it gives you all the information, applications, and everything. So that's our output. We can see the computer name here, PSU Mac 01, and then a little information about hardware. And we'll talk in the future exercises about how to get that information in a more readable format. Okay. So any questions on exercise 3 before we move on? Adding those commands into the end of the script before exit 0? Okay, go ahead.
Okay. All right, so next we're going to talk a little bit about software version and disk utility. And here what we want to do is we want to get the OS 10, the product name, all right, the version, the build version. Also, we're going to print out hardware, hard drive information. In this case, the size, available space, the type. All right. And then finally, core storage. How many of you know what core storage is? How many of you have no clue what it is? Well, that was me a couple months ago. So, Rusty?
Oh. Yeah. So core storage is Apple's new technology behind fusion drives. Core storage allows you to take two physical volumes and create a virtual volume that is shown as one disk, one volume. You can use multiple drives. I'm not sure there's a limit, but I think you have a limit on the number of partitions. I think there's 2 partitions you can have for core storage volume groups. Also, FileVault has a limitation on partitions.
No, I mean.
Oh, core storage uses FileVault uses core storage. Yes, thank you. I forgot about core storage.
And you have to specify in the command that it is core storage that you are looking to get information about.
Yes. Correct. Yeah, 10.8. If you mount a Fusion drive on 10.7 and before, it shows us 2 separate volumes, hard disks. So, exercise 4. This is the last part of the script before we start to clean it up. We add at the very end disk-util commands to show all of the disks that are on the machine and show info for a couple of the disks, show the core storage groups, and then an info for the core storage group, which is usually disk 2, but it may be separate for you. So in the terminal, if you run disk-util cs list, if you have a core storage device, you can see what disk identifier it shows up as.
One important note, if you're looking at this script either on the screen or on your machine, notice all the comments that we've put in there. It's really important to put lots of comments in there. Blank lines, that's not a problem for the interpreter. It doesn't care about blank lines. So you'll see that some people that do very complex shell scripts, they could have a complex shell script that's 50 lines of actual code, and they may have 200 lines of comments documenting what that code is.
So you may get some error commands here for core storage at the end. Could not find disk 1 for disk info. Disk-util info disk 1, there's only a single volume. Disk 0. Core storage, no logical volume groups found, and no disk 2. So that's the expected output. Now, if you think about this script as being something that's going to be movable between machines and between OS versions, you have to start building in some more logic. And if you don't want to see those error codes in the output.
Well, yeah, what you could do is if you know that you're going to be running this machine, this on a particular machine, and it's not a complex script, we're testing for something, you could simply comment that particular line of code out.
Yes.
As well.
So we're going to talk a little bit about basic regex. We're not going to get too deep into it because it's confusing to me. But we're going to...
Short for regular expressions.
Yes, regular expressions, thank you. A couple of them that we want to touch on are the beginning of line. So if you're searching for a string and you want to match the beginning of line, you can use the caret. If you want to match the end of the line, you can use a $, and we'll see end of the line $, in the next slide. All characters, any number of them is the star. All characters, matching all characters and numbers, but only a single instance is the dot. Period.
So, real quick side on regular expressions. If you can't fall asleep reading the man page, you can grab a book on regular expressions, and I guarantee you, it doesn't matter how much coffee, how much caffeine you've had, it'll put you to sleep. It can be very complex, but you can really do some very strong programmatic, thank you, scripting with regular expressions. And as Rusty said, these are just a couple of them.
There's also extended regular expressions, which are another beast. grep. We're going to use grep as well in our script to help kind of clean up the output of some of these commands. Grep does a search and a match, so you tell grep what to search for. If it finds a match, it'll print it out to the standard output. You can use -i flag to ignore the case in your search pattern. If you want to print the next 5 lines after your match, you can use a -A5 or any number that you want. If you want to print the lines before your match, you can use a -B and the number of lines there.
Capital A, capital B.
Correct. No space between that and the number. So here's an example of grepping the output of the network setup list all hardware ports. Now, we had a lot of information there, but really, I don't care about the Bluetooth stuff. or the FireWire stuff. I'm only really interested in the Ethernet and Wi-Fi information. So what I can do is I can grep that output for Ethernet $, and that looks for the Ethernet string at the end of a line. If I don't use a $, I end up getting the Ethernet from every Ethernet address line matched and printed to the standard out. And I also want the rest of the information on the Ethernet hardware port, so I do a -A2 to print out those next two lines. Now, how do we get those grep and the other command together? We do piping between commands.
So pipe is a really, really useful tool. What it does is it takes the output that's on the left side of the pipe and sends it to the input on the right side. So it takes the output of one command, and instead of it going to your standard output, it redirects it to the input of the next command. All right? So we do that simply by doing, for example, network setup, list all hardware ports. We know that will give us a lot of information. So we say, no, we're going to take that output, we're going to send it into grep, and we're going to say, search, or give me everything that matches with an ending of Ethernet and the two lines that follow it. So any line that ends with the $, anything that ends with Ethernet, give me that line followed by the next two lines after it.
So this gives us a much nicer output of the Ethernet information, and we can also use that for Wi-Fi to get the Wi-Fi information.
If we hadn't put the A2, the only thing you would have seen there was hardware port : Ethernet. But we wanted to capture all that information.
So for exercise 5, we're going to grep the output of network setup, list all hardware ports for Ethernet, Wi-Fi, and return the 3 lines from each. So we're going to look at exercise. So I'm going to pull up inventory script number 5, which includes the greps. And then I started also doing a little bit of organizing with some comments. You could run a bunch of comments together with a little word in between to create sections in your script. We didn't talk about this in the slides, but it was just a kind of a personal habit. So here we go. So we're grepping here, network setup, grep -A2 Ethernet $, to get that Ethernet, -A2 to get the Wi-Fi information. And if I run this script, we can see the output up here, inventory script, hardware Ethernet port, 3 lines, Wi-Fi, 3 lines. That's correct. So that's a great question. How do I know what to grep for? If I run network setup in the terminal, this is 5. This is the output that I get from network setup. I don't know why I see VLAN configurations. I don't need it, right? So we want to grep for just the information we need. I can see Ethernet. I want that. I can see Wi-Fi, which I want. You may see Ethernet 1. You may want FireWire. But you find what you want to grep for, and when you pipe that output into grep, you can match that. Now, like Jay said, I didn't add the -A2, so I only got that single line. With A2, I get the next 2 lines. I think that's it for exercise 5. Let me switch back.
Go ahead. Variable.
Yep.
Okay, so we've talked about variables a little bit. You set it with an equal sign. In this case, VAR equals 10. It could be banana equals 10. Then it's in the value of banana to equal 10. In this case, VAR or VAR equals 10. If you want to get the value of a particular value, or excuse me, value of a particular variable, you have to precede it with the $. Right?
Redirection allows you to take. Question? Yeah. Yes. Can I answer that in like 3 slides? Perfect. So, real quick, redirection allows you to take the standard output and put it into a file or another location. Has anyone heard of dev null? Basically, dev null is like the trash can. If you don't want to see the output, redirect it to dev null. In this case, we want to redirect things into a text file. So here's an example. If we echo hello1 with 2 pipes into file.txt, and then chevrons, thank you. And then echo hello2 with 2 chevrons into file text, and then we cat out that file, print the file, whatever is in the file, we see hello1 and 2. If we echo hello3 with just 1 chevron, what the shell does is it wipes out that file's contents and then echoes that text into the file. So when we cat it, we only see hello3. So those are the basic redirections. TR allows us to, in this instance, delete a pattern out of a string. So previously we saw VLAN's configuration. If we didn't want that, we could copy that and put it into TR-D pattern, and that would remove that from our output. We're using it with System Profiler to get the serial number, and we're removing the word serial number from the front of it. So the only output will be the serial number itself. This may be helpful if you need to pass that into another script like a warranty script that would read that serial number and then give you information on the warranty. To your question, command substitution, do you want to? I stepped on you. Sorry. You can put a command inside a $, parentheses, thank you, and set that to the variable. So variable equals $ parentheses will evaluate what's inside there and set it to the variable. So who am I for the username variable? Username equals $ parentheses who am I. It sets that variable after running the who am I command. So the output of who am I goes into the username variable. We echo that out, and we get root. For instance.
Answer your question?
So for exercise 6, we're going to grep and redirect. We're going to take System Profiler, and we're going to look for just memory, model identifier, process type, processor speed. We're going to set a variable for a file name. We're going to output all of the text we're getting so far to a file, and we're going to name the file based on the user that's logged in and the serial number of the machine. So I'm going to switch to inventory script 6. This is where things get a little bit more complicated. So the very first thing we do is grep System Profiler. Let me scroll down here. And you can see what we're grepping for. So we pipe in System Profiler SP hardware data type into grep. We look for memory here, and then we'll output that to our variable file output, which we'll talk about in a second here. We grep the System Profiler 4 times for each piece of that information. So instead of seeing the entire output of the hardware data type, we're only seeing those 4 lines, the actual information we want. You can see that all of our commands now are also outputting to the file with 2 chevrons. At the very top, I've got a couple different things set. The first thing I have set is a serial number. That uses our command substitution again to run System Profiler, the command we looked at before, grepping out the serial number and removing the serial number name, so that if I run this command in the terminal, the only thing we see is the serial number, no other information. So I can use that to set the variable serial number. If I copy and paste that line, I've just set the serial number variable to the output of that command. And if I echo serial number, I get the serial number. So I can take that serial number variable and use it in my next variable called temp file. So this is the name of the file that we're outputting to. I also used command substitution in the temp file name, so you can see you don't have to create another variable and use that in another variable. You can actually do command substitution within the variables. I could do multiple command substitution. I could do who am I, hyphen, and then another command substitution for serial number. Doing it this way makes it a little more readable for me, and it also allows me to reuse the serial number variable later on. We then set the file output to the, anyone? What is this, absolute or relative path? Yep. So we set the file output to the relative path and then the temp file variable. Any questions on that?
Yep.
I like that variable.
Correct. So we talked a little bit about parent and child shells. The child inherits the variables from the parent, but does not export those variables back to the parent unless you tell it to export the variable. And then it exports it to the parent shell, I believe, when it closes. Quick question. So yes, these variables are unique to this run of the script, and then they're wiped out. So if I went back in and I open up a new window, there is no serial number variable set in this new shell. Okay, so we've outputted everything to the script, and I'm going to run it real quick just so you can see what you're not going to see. You're only going to see the errors, because standard out and standard error are actually two different pipes. Can I use that word? So we're only redirecting standard out. Not 100% on that, but I'm going to move on.
Yes. All right. Since we're at the end, I don't want to keep you guys beyond. So here's a couple of good resources for you to continue. First one, TLDP, Linux Documentation Project.org. I know it's Linux. Sorry. But it is an excellent resource for shell scripting. So just remember TLDP.org. Just go there and you can see they've got a whole bunch of different guides and so forth on there. Lifehacker.com, also a great site. I'm not familiar with mywiki.fulledge. Is that you, Rusty? Fulledge?
Yeah, there's a bash guide there.
Bash guide. Developer.apple.com. Again, if you can get your developer ID, that would be great.
Open source.
Their shell scripting guide, yeah.
They don't know about it yet.
Yeah, so thank you everyone for coming, and appreciate it.